so delighted that you are watching my YouTube channel. I'm your presenter, Teacher Jonathan Musao. Today I'm taking you through KCPE 2014 Mathematics paper from number 18 to number 30. If you are a candidate or a class 7 pupil, I would prefer that you take a copy of the KCPE 2014 or Booster or any other book that has those questions, and we go together. Don't forget to get your set also, because I'm going to do the constructions which are in those numbers. Welcome. Construct a circle center O using line ROS given below as a diameter. This is the given line ROS. Construct angle QRS, which is 30 degrees. Mark point Q on the circumference and draw line QO. What is the size of angle QOS? So the first thing is to draw the circle we are told to draw, having the radius of OS, because we are told that O is the center, so we have to stand at O, and with the radius OS we draw the circle like that. After that, we want to construct angle QRS, which is 30 degrees. So we take our protractor, we strategically place it at R because we want QRS. Q will be somewhere here, and then we mark off 30 degrees. So using the inner scale, we mark 30 degrees, which is up to there. Then we join with the ruler. Remember, the line goes up to the circumference, not beyond the circumference. So that is 30 degrees line. So I get my pencil, I draw a line from R to Q so that I can have QRS. So this is point Q. This is my point Q. And it's such a way that QRS is 30 degrees and Q is on the circumference. Draw line QO. So we join from Q to O, to the center of the circle here. We join the straight line and a ruler from Q to O, like that. Then the question is, what is the size of QOS? We have to measure this angle here, where there is this star here. So before we measure the angle, we have to look at the type of angle we are about to measure. And this is an acute angle, which is less than 9 degrees. So looking at the choices given on that question, 150 degrees is out, because that's an answer for obtuse. 120 is out. 90 degrees, it's supposed to be a right angle. So we are left with 60. But just for the sake of measuring, we have to measure, but we are going to be certain that the answer will be 60, because in the choices they have given, we don't expect another answer to be correct. So we get from 0, using the inner scale, 10, 20, 30, 40, 50, exactly 60. So that is 60. And for those candidates who are not keen, they will be trapped by answer B, which says 120 degrees, because once I've placed my protractor, if I don't mind about the scale, the answer that comes straight is 120 degrees. So it is very important to make a judgment the type of angle you are measuring before you measure, so that you don't use the wrong scale. So our answer is 60 degrees. The table below shows the number of fruits sold by Fatuma and Bidi on a certain day. The number of bananas sold by Fatuma and Bidi has not been shown. So looking at this table, we have the fruit seller, who is Fatuma and Bidi, and then we have the number of oranges for Fatuma, we have 84, and Bidi 135. Number of melons for Fatuma 8 and Bidi 12. So we are not given the bananas for Fatuma and Bidi. So and the number of mangoes for Fatuma is 120 and Bidi 60. The total for Fatuma was 277 and Bidi 315. How many more bananas did Bidi sell than Fatuma? So to get the number of bananas for Fatuma, we first look at all this total we are given of 277 includes those bananas which are not given. So we are going to add for Fatuma the oranges, that is 84, plus the 8 melons, plus the 120 mangoes. Then we take away from 277 to get 65 bananas. BD we do the same. We get the oranges, which are the 135 plus 12 melons plus 60 mangoes, put them together, then subtract from the total 315. We get 108 bananas. So we now know the bananas for Fatuma and BD. So how many more we subtract to get the difference? 108 minus 65 to get 43 more bananas. Below are 4 different types of triangles. Which one of the following pairs of triangles correctly describes the types of triangles above? Just to go through the triangles, the first one, which measures 5 centimeters, 5 centimeters, and 4 centimeters, that's an isosceles. We know an isosceles has 2 sides which are equal and 2 angles which are equal. The second triangle, which has got 4 centimeters, 4 centimeters, 4 centimeters, that's an equilateral triangle. Equilateral, all the sides are the same and all the angles measure 60. Then the third triangle, which is drawn like a right angle triangle, but it is not a right angle triangle. And we can know that it is not a right angle triangle by squaring 16 plus this side 4 and the other side 4. And if you have that and you find the square root, you will not get 5.7. So it is just drawn like that to confuse you. So that is an isosceles triangle because of the 2 sides which are equal. So the third triangle is an isosceles simply because of the 2 sides which are equal, 4 centimeters and 4 centimeters. Then the last triangle, which has got 4 centimeters, 5 centimeters, and 6 centimeters. None of the sides are equal, and such a triangle is called scalene triangle. So going by the choices, choice A, which says Roman 1 is and Roman 3 isosceles, is very true, because Roman 1, you can see 2 sides are equal, 5, 5, and Roman 3, 2 sides are equal, 4, 4. So both are isosceles triangles. Question number 21 is about scale drawing. A road measuring 5 centimeters on a map has an actual distance of 15 kilometers. What is the scale used in drawing the map? So in this question we have to make sure that the units are the same. And for us, before we change it into ratio form. So the actual distance and the drawing length must be the same. So 5 centimeters represents 15 kilometers. The kilometers has to be changed into centimeters. 1 kilometer is equivalent to 100,000 centimeters. 1 kilometer is equivalent to 100,000 centimeters. So to convert 15 kilometers, we multiply by 100,000 centimeters. So 15 kilometers will become 1,500,000 centimeters. So the linear scale now says 5 centimeters represents 1,500,000 centimeters. Now the units are the same. The second step is to simplify both sides by 5. Both sides we get 1 centimeter represents 300,000 centimeters. And after simplifying and making sure that the units are the same, we now write it as a ratio. 1 is to 300,000. Number 22, it's about commission. A car dealer was left with 855,000 after paying out a 5% commission to an agent for the sale of a car. What was the selling price of the car? So if we analyze this question, we know the selling price of the car was the price before he paid the agent. So that is the 100%. Then the commission that he paid out was 5%. So he was left out with 95%, and that is what we are given. 95% is what he was left with after paying an agent, because the question starts by saying a car dealer was left with 855,000 after paying out a 5% commission. So 95% is what he was left with, because originally it was 100% the sale of the car, paid a commission of 5%, so he was left out with 95%, which is now represented by 855,000 shillings. So what was the selling price of the car? In other words, we are looking for the original price before paying the agent. So we get, if 95% represents 855,000, what about 100%, which is the original price before paying out the commission? So after you cross multiply 100 times 855,000 and divided by 95, we get 900,000 was the price, was the selling price of the car. And looking at this answer, it makes sense because the answer is supposed to be higher than what he was left with. Question number 23 is about graph. Below is a graph showing the journeys made by Bakari and Omar. Both started at 7 a.m. Bakari started from town J to town K. This is Bakari who started from town J all the way to town K. K is up here. Then Omar started from town K to town J. Omar started from the top here, from K to town J down. Then after traveling for 3 hours, Bakari rested for 30 minutes. So this is Bakari's journey, who traveled for 3 hours from 7 to 10. Then he rested for 30 minutes. This is the rest. Then the question, how far from town J? How far from town J was Omar when Bakari started his rest? So we want to see how far from town J was Omar when Bakari started his rest. So Bakari started his rest at this point here. At this particular time when he started at the race, it was 10 a.m. So at 10 a.m. where was Omar? So we move down with the same line of 10 a.m. until we meet Omar. So we meet Omar at this point here. So from at 10 a.m. when Bakari started the rest, this is where Omar was. Then at this point, to get the distance, we move across up to this end here. We have to know the scale used so that we can be able to identify this distance. So we know for 1 centimeter on the vertical axis represents 50 kilometers from 0 to 50. And these 50 kilometers are in 5 small squares. So if you divide 50 by 5, you get 10. So every small square represents 10 kilometers. So starting at 200, at 150, we go by the 10 kilometers, we go to 160, 170, 180. So the time Bakari rested, Omar was at 180 kilometers, and then we want to know how far from town J was he, and town J is down here at 0. So we take away the difference between 180 and 0, which is 180 kilometers away from town J. I repeat again the question. So how far from town J was Omar when Bakari started his rest? So we go up with Bakari, you see where the rest started. The rest started at 10 a.m. When I'm standing here, this is 10 a.m. And at this time, 10 a.m., we move down until we meet the line for Omar. So at this time, Omar was at 180 kilometers away from J. And I've said it's very important you identify the scale used on the vertical axis, because if you don't identify the scale, you are going to get the wrong answer. So the scale we have identified by saying 1 centimeter on the vertical axis represents 50 kilometers. And these 50 kilometers are in 5 small units. So we divide 50 by 5, we get 10 kilometers. So every small square is 10 kilometers. So from 150, we move 150, 160, 170, 180. So at this time, Omar was 180 kilometers away from town J. Number 24 is a question on substitution, where we are supposed to replace the knowns with the values that are given. So the question says 2x plus 3y plus 4z over, into brackets, yz squared. So if x is 2, y is x over 2, and z is 3y. Then before we go to solve the question, we have to know the value of y and the value of z. We are only given the value of x direct. So y equals to x over 2, and we know x is 2. So y will be 2 over 2, which is the same as 1. Z is 3y, which means 3 times the value of y, which is 3 times 1, which is 3. So x is 2, y is 1, z is 3. Then to solve the problem, we say 2x means 2 times 2 into brackets plus 3y means 3 times 1 plus 4z means 4 times 3. Then in the denominator side we first work out what is in the bracket, yz, which is y times z, 1 times 3. Then after we get the answer, we square it. So on the numerator we have 4 plus 3 plus 12, which is 19. On the denominator we have 9, which gives us, when changed to improper fraction, it becomes 2 and a 9th. Number 25 is a question on surface area of a cylinder. And we are told an open cylindrical tank has an internal diameter of 5.6 centimeters and an internal height of 4 centimeters. The inside of the tank was painted. What area of the tank in square centimeters was painted? So the key words in this question is the inside of the tank was painted. So when you paint the inside part and it's opened, you paint the curved and the bottom. The top is not there because you are told it's opened. So you only paint the curved and the bottom. The curved, you work out the area of the curved, which is pi dh, plus the area of the bottom, which is circular, which is pi r squared. So you multiply pi dh, which is 22 over 7 times 5.6 times 4. Remember, in pi dh you use the diameter. When you are working out the area of the circle, you use the radius. So you convert this 5.6 divided by 2 to get the radius, which is 2.8. So pi, which is 22 over 7 times radius times radius. So 22 over 7 times 2.8 times 2.8. These two give us 70.4 plus 24.64, which is 95.04. So in this question, you only to find the surface area of the curved and the bottom, the pi dh and the pi r squared. Number 26, it's a question from the topic of speed, distance and time. Kibet left school by bicycle at 8 a.m. and took 1.5 hours to reach the market 20 kilometers away. Akinyi left the school for the market by car at 8:30 a.m. The average speed for the car was 80 kilometers per hour. What was the difference between their arrival times? So we first analyze what we are given. Kibeti's departure time was 8 a.m. He took 1.5 hours and the distance that he covered was 20 kilometers. So arrival time for this one is supposed to be departure time plus time taken. Arrival time is departure time plus time taken. So nothing is hidden for this question to find the arrival time, because we have the departure time 8 a.m. and it took 1.5 hours. So it is 8 a.m. plus 1.5, which becomes 9:30 a.m. So he arrived at 9:30. When we come to Akinyi, that's where some of the information is hidden for you so that the question can confuse you. So departure time, Akinyi started at 8:30 and she was traveling at a speed of 80 kilometers per hour. Remember, they were traveling the same distance. So you are not given distance here, but it is good to know that they were to cover the same distance. So the distance is 20 kilometers. So having speed of 80 kilometers per hour and a distance of 20 kilometers, we can get the time she took. Time equals to distance over speed. So we get the distance she covered, 20 kilometers, divided by the speed, 80 kilometers per hour, which gives us 1/4 of an hour. So she only took 15 minutes to cover that distance. So to get her arrival time, we get the departure time. She left at 8:30, she took 15 minutes, and then she arrived at 8:45 a.m. So the final question is asking what was the difference between their arrival times. So we get the arrival time for Kibet, which was 9:30, and the arrival time for Akinyi, which is 8:45, and then we subtract, which gives us 45 minutes. I repeat, for the part of Akinyi, we are told that Akinyi left the school for the market by car at 8:30 a.m. That was the departure time. The average speed of the car was 80 kilometers per hour. So we are given the speed, but it has not mentioned about the distance. But we have to know that they were traveling the same distance, which was 20 kilometers. So having a speed of 80 kilometers per hour and a distance of 20 kilometers, it's upon us to know that we have to get the time she took. And time is given by distance over speed. And we divide distance, which is 20 kilometers, by speed of 80 kilometers per hour, 20 over 80, which gives us a quarter when simplified. And a quarter of an hour is 15 minutes. So arrival time for Akinyi will be departure time plus time taken. She started her journey at 8:30 and she took 15 minutes. She went faster because she was moving by car. So the difference in their arrival times is the question. So we get Kibet, who arrived at 9:30, and Akinyi, who arrived at 8:45. We subtract and get 45 minutes. Number 27, which is a question about compound interest. Molly invested 10,000 in a bank which paid compound interest at the rate of 8% per annum. How much money did Molly have in the bank after 2 years? So I've used a formula which says amount equals to principal times rate plus 100 over 100 times rate plus 100 over 100. It's a very simple method which will give you the total amount which he had by the end of the second year. So what you do in such a formula, you get the rate for the first year, you get the rate which was 8%, add 100 to that rate, it becomes 108. Then you put over 100. For the second year, you get the rate again, add 100 to that rate, it becomes 108. Then you put over 100. Then you multiply that principal times the first year and the second year. And then when you cancel all this and multiply, you get 11,664 as the answer. So in other clips that I posted in my YouTube channel, I've also captured how to calculate compound interest using the same method and also using the long method, and also at times when you are given 1.5 years. So don't miss out to watch the same on other clips in my YouTube channel. Number 28, what is the next number in the pattern below? 7, 12, 19, 30, 43, then dash. To get the next number, we are supposed to check what is happening between the first and the second number. That is 7, we have added 5 to get 12. 12, we added 7 to get 19. 19, we added 11 to get 30. 30, we added 13 to get 43. So looking at these numbers, 5, 7, 11, 13, we can tell these are prime numbers. But a candidate is easily able to be convinced that these are odd numbers. These are not odd numbers. If they were odd numbers, they would move from 5 to 7, then to 9. Remember, odd numbers, we only skip one and then move to the next one. So if they were odd, it would be 5, 7, 9, then like that. But these are prime numbers. We know the first prime number is 2, followed by 3, followed by 5, then followed by 7, then followed by 11, then 13. So after 13, the next prime number would be 17. So from 43, we add the next prime number 17 to get 60. So be careful not to confuse odd and prime numbers. Number 29 is a question about bus timetable. The table below shows a bus timetable for Isiolo to Mombasa route. We have the name of town, the arrival time and the departure time. Then we have the towns and their departures and the arrival times. How long is a bus expected to take to travel from Nyeri to Mtito? So how long is asking about time taken. Remember, time taken is achieved by getting arrival time minus departure time. Take note, it's arrival time minus departure time. Never say the opposite. That is departure minus arrival. Never. It is arrival time minus departure time. So we are going to get this. Nyeri will give us the departure time. Then where he was going, that is Mtito a day, will give us the arrival time. So we start with the arrival time of Mtito a day, which is 2:30 p.m. Then we subtract the departure time from Nyeri, that is 4:15 p.m. Some candidates, when they see that the first number is smaller than the second number, they interchange and subtract, and that is where they fail. So the formula says arrival time minus departure, whether it's small or not. So 2:30 minus 4:15 p.m. To make it workable, we add 12 to this 2:30 to become 14:30. Then we subtract 4:15, and this gives us 10 hours and 15 minutes. I repeat and insist, time taken is arrival time minus departure time. So whether it's a small number or a big number, time taken must be arrival time minus departure. So Nyeri represents the departure, the start of the journey, and he left Nyeri at 4 p.m. He left Nyeri at 4:15 p.m. He arrived Mtito a day at 2:30 a.m. So he left Nyeri, departure time was 4:15. He arrived Mtito a day at 2:30 a.m. So get the arrival time 2:30 a.m. from Mtito a day, and the time he had departed Nyeri, that was 4:15 p.m. If you do that, you will never fail such questions. And number 30 is a construction of a robust. Below is a part of a robust PQRS. Line QS is one of the diagonals, and line QR is one of the sides of the robust. Complete the robust. What is the difference in the lengths of the diagonals? So underline QS is one of the diagonals. This line here, QS, is a diagonal. It's not a line. The only line we are given here is QR. So QR is one of the line, the other one is a diagonal. So to locate the other line, we are supposed to join R and S. R and S represents the other line that we are not given. So you get a ruler, join from point R, S and R, just like that. So you now have point QR and RS as the two sides. These are diagonal, it's supposed to be inside. So now we know in a robust all sides are equal. So we are supposed to take the measurement of QR with our compass. We stretch the compass to give us the length of QR. We stretch the compass to give the length of QR. Then standing at point Q, we make an arc on this side where we expect our point P to be. So we make an arc here. This is where we expect our point P to be. And again, standing at the new point S, we make an arc with the same radius, because all sides of a robust are the same. We make an arc to join here to locate point P. So that's our point P. We name it P. This is our point P. Then now to complete the robust, we join point P to Q, point P to Q, the ruler. You also join point S to P with the ruler again. So we have completed, and you can see the line QS is inside. It is one of the diagonals. So this is one of the diagonals. Now we draw the other diagonal by joining from point P to R, like that. So we have the two diagonals. The next thing to do is to measure the diagonals because we want the difference between the two diagonals. So we measure the diagonals. We measure the first diagonal, which is exactly 6 centimeters. As you can see in one of the choices that is there, which tells us that we are still sailing in the right boat. The choices reflect whether you are working out in the right place, the right way. You measure the other diagonal, you place it at point P, and you place this one here, and you can see it is exactly 12.5. You can also see it in the choices. So now the difference between 12.5 and 6 is 6.5. So the difference between the two diagonals is 6.5. That is the answer.